Econ Industries is the production center for cost-effective, energy-efficient CEEF building materials. The center produces a wide range of reinforced concrete and prefabricated ferrocement products, such as concrete hollow blocks in 3 different sizes: 4-inch, 6-inch, and 8-inch blocks, ferrocement roofing channels, prefabricated ferrocement toilet components, pavement tiles, concrete door frames, and concrete window frames. Hollow block raw materials are chips, 8 to 12 millimeters, cement, OPC 43 grade, fine sand, and stone dust. The concrete hollow block production process involves 4 steps. The water-to-cement ratio is between 0.45 to 0.5 per kilograms of cement. For 1 metric cube of hollow concrete block, 300 kilograms of cement is required, 0.45 metric cubes of sand, and 0.95 metric cubes of chips. The consistency of the mix should be such that it will cohere when compressed in the hand without trace of excess water. Hollow blocks are gaining popularity for use in freestanding walls and building walls and can be constructed at a fraction of the cost of traditional brick or cement walls. The air gap in the hollow blocks acts as a thermal insulator, keeping buildings cool in summer and warm in the wintertime. Hollow blocks are larger than solid bricks and are not heavy if lightweight aggregate is used. The second step is the casting of the blocks. Blocks are made using a machine utilizing vibration and compression mechanisms. The mixture is placed in the mold, and using a vibro-compression process, they are compacted into the mold. This process ensures that any voids and air pockets are minimized in the blocks to achieve the desired strength. The third step is the curing stage. Blocks are then covered with a plastic sheet to protect them against sun and strong winds. They are kept like this for 12 to 24 hours until they have sufficiently hardened to permit handling. After 24 hours, the blocks are placed in a stack and covered by jute gunny bags. Water is poured over the gunny bags for a period of 14 days. The fourth step is the drying stage. After 14 days of wet curing, the blocks are dried for 1 to 2 weeks. Monitoring quality control of the finished product is an important step. A block density test checks load-bearing capacity. A 28-day-old block is selected from the lot. The weight is determined to the nearest 10 kilograms, and results are cross-referenced with the IS chart. Compressive strength test is the second essential checkpoint. Blocks that are tested for compressive strength should be 28 days old. All hollow blocks are tested with their cores in a vertical position. Blocks should be checked for dimensions and inspected for visual defects, such as cracks. A minimum of 20 samples should be taken from every batch of 5,000 blocks. The machine is operated until the black needle slips down, leaving the red needle at a point. The reading indicated by the red pointer is the maximum load the block can withstand. Only blocks satisfying these quality standards will be deemed ready for sale. Econ promotes its CEEF products for social housing to rural villages through SEVE, an NGO working in 362 village communities in the Tiruchirappalli, Karur, Erode, and Nagapattinam districts of Tamil Nadu. SEVE is also engaged in promoting energy-efficient, eco-friendly housing projects on a credit basis in Trichy and Karur districts. Self-help group members and beneficiaries work alongside masons to actively participate in the housing construction process. There are two kinds of houses: single houses and twin houses for larger extended families. Features of these houses are adjoining toilets, smokeless chillas, decorative cement tiles, and kitchen gardens. A ferro-cement channel is an alternate roofing material that is placed side by side on top of the walls of buildings. It can bear the same load as a conventional roof. Another benefit is that floors can be raised above structure with ferro-cement roofs. A precast ferro-cement channel is a lightweight roofing material which is made of a ratio of 1:2 cement and sand mortar and mild steel reinforcements. Some advantages include: it is suitable for earthquake-prone areas, it is lightweight, and requires less cement and steel. The casting of a ferro-cement channel occurs on a ground mold, using steel rods for reinforcement. Casting a channel roof. Apply a coat of burnt diesel oil or demolding oil over the surface of the mold. Spread a coat of 10 millimeters of mortar uniformly over the surface. Place a reinforced mat over the first coat of mortar and press gently but firmly. Apply the second coat over the mat and compact using trowels to ensure infiltration of mortar through the mat. Apply further coats to achieve required thickness. Finishing, curing, and drying are the final steps. Demolding of the channels should be done at least 24 hours after casting. This period is required for the channel to develop sufficient strength to enable self-demolding. Ferro-cement toilet components. Prefabricated ferro-cement structures for toilets can be erected in one day. The cost of such toilets can be 50% less than conventional models. The production process for toilet components is the same as the ferro-cement roofing channel. Applying a coat of burnt diesel oil over the surface of the mold. Spreading a coat of mortar uniformly over the surface. The exception is the change in the reinforcement material. Diamond mesh is used for the base plate and no steel rods are used. The channels are then finished, cured, and dried. In addition to the side walls, other components of ferro-cement toilets are the base plate and the top cover, the leach pit and leach pit cover. Pavement tiles are both decorative and functional housing components. Square, diamond, and zigzag are the three designs which are available. Tiles are made of cement, OPC 43 grade, fine sand, maximum grain size 2.36 millimeters, chips less than 2.5 millimeters to 12 millimeters, quarry waste, maximum grain size 2.36 millimeters, and the cement to water ratio. The blocks are made using a vibro-compression mechanism, and the demolding of the tiles is accomplished using a manual demolding press. In collaboration with local government departments, Econ designed and built the first public and government buildings to use CEEF housing materials in Trichy and Coorg districts. Such buildings are the St. Dominic School Building at Kalutalai and the Rural Technology Center in Surugamani. The Farmers Market Building in Anandagar, Trichy. The canteen and office buildings have been constructed using low-cost materials. Hollow blocks were also used for the vendor stalls in the marketplace. Low-cost materials are also used to build public and private sanitation facilities. Community toilet complexes are installed in urban areas, while individual toilets are used in both rural and urban settings. The Women's Police Station in Trichy combines aesthetic design and functionality, featuring unique roofing design, and use of verandas. The construction of the Police Information Center in Trichy. Rural TV rooms. Government school buildings. And the school building, the Save School at Pichandar Coville. Rural housing construction projects include the villages of Laugidi, Kulivalur, and Kilivalur.